Like, as you know, from today onwards, we are going to start our class 12 syllabus, which we call it as the first chapter of that is we know that it is called as electrostats, isn't it? Now, before going to before going to do too much depth about this chapter, there are some basic pre-requirements of the chapters which we are going to fulfill and which we are going to understand, isn't it? So let us first understand what this chapter itself is trying to say to us. Okay, like here there are two words which are coined together. Okay, like you can see the first word is this electro, and then this one is statics. Word basically, the word electro is nothing but it is saying something called as the word electron. And static means we know that not moving. Yeah, so initially there was an idea that only electrons moves or something like that. So that is why they gave this name as electrostatics. But basically this chapter is related with charges. हम charges के बारे में basically mainly बात करेंगे. The charges which are at rest. Okay. Are you able to get me or not? So this chapter deals about the charges which are going to be at rest. They are not moving. They are not going here and there, and that's why this chapter is called as electrostats, isn't it? ठीक है. Now, the first question which develops in our mind due to this, that what is this charge, isn't it? What's the meaning of this word charge? है कि नहीं? So in many physics books, you will get many ideas and many descriptions. See, there are something like if I ask you what is mass, so you can't describe. You can just say that it is nothing but which composes matter, amount of matter. Similarly, charge is nothing but we define that it is the source. It is the source of electric and magnetic field. It is nothing but the source of electric and magnetic field. What means whatever is there at some abundant or wherever there is a presence of electric field and magnetic field, we say that it comprises of charges, and that's how the basic entity, the word charge is given to the some definite amount of matter or something like that. Word or not, ठीक है. तो अब पॉइंट आता है, सिंपल सी बात है कि हमारे पास जो मैटर है वी नो दैट और मैटर is composed of two things. We can say not like that. We know that our matter is composed of atoms, isn't it? Now, atom gives us two ideas. One thing, the atom, in an atom, there are two main things. One we call it as nucleus, another one we call it as electrons, isn't it? So, in atom, we know that whole matter is composed of our atoms, and that atom is divided into two parts, nucleus, and then we have electrons. While the nucleus consists of two more things, one we call it as neutrons, and then we have protons. And the combination of these three particles, these three different entities, we call these as charges. Are you able to get me? So basically, we have three different kinds of charges: electron, protons, and what? हम इसीलिए तो बोलते हैं कि न्यूट्रॉन इज अ न्यूट्रल चार्ज. It has a charge. It has a neutral charge. What is the meaning of does not have a charge? That means neutral. Yeah, you have to say neutral. So similarly, proton has positive charge, and electron have negative charge. Is that clear or not? Now, these are the basic building, means you can say the basic properties of materials, है ना. सेकेंड पॉइंट एक और चीज के बारे में डिस्कस करेंगे. द masses of these bodies, we know that mass of electron is given as 9.1 into 10 to the power of minus 31 kg, while the mass of proton is given as 6, 7, 10 to the power of, sorry, minus 27. No, minus 27 kg. So this means what? This means once again one more property, that electrons are lighter than protons, isn't it? So if someone asks you which can move faster, the faster moving particle in the universe can be only electrons, because even electrons are even smaller than protons. Are you able to get me or not? But yes, the photons are very very small massless particles which the light consists of. They are even, photons are even smaller, and that is why we say that the light is the fastest moving entity present in the universe. Right or not? Okay. Now let us understand what is actually the meaning of these charges actually. ठीक है. So what these charges help us is, so charges help in charging. There is a property which we call it as charging. Okay. Now the point is how the charging is done. So charging is done by the process. Okay. Charging is done by supplying electron or taking out electron, or by taking out electron. Got it or not? So see, we are coming on this. First, we got to know about the charges. I didn't talk about those quarks and all. We'll talk about that. There are still some basic properties or basic entities of these protons and neutrons. Okay, which we call it as quarks. We will discuss it later on, and I think I'll discuss that about that in atoms, nuclei, and all. Okay. Here we are going to discuss in a brief way. So charging is done basically if we want to charge anything. So charging is done by supplying electron or by taking out some electron. Remember that many people say that मान लो ये बॉडी है, ठीक है ना, इस बॉडी के ऊपर पॉजिटिव चार्ज लाना है, तो बहुत लोग बोलते हैं पॉजिटिव चार्ज डाल दोगे तो पॉजिटिव चार्ज आ जाएगा. ऐसा कुछ होता नहीं है एक्चुअली. द रिमूवेबल charge which is present in the universe is only electron. Right or not? Because protons are found inside the nucleus. So you can either take out the electron or you can either bring the electron. So let's suppose if I have a conducting body, है ना, तो इस बॉडी से अगर मैं चार इलेक्ट्रॉन को बाहर निकाला, ठीक है ना, electrons are taken out, then this particularly body, yeah, it will become positively charged. Okay. That means if it is positively charged, one more property is that when you think of positively charged, you can say that this body is an electron deficient body. ठीक है. सो ऐसा नहीं होता कि पॉजिटिव चार्ज हम मतलब पॉजिटिव चार्ज प्रोटॉन्स एक्स्ट्रा दे के बनाते हैं, ऐसा नहीं है. हम क्या करते हैं, इलेक्ट्रॉन्स के ऊपर बात करते हैं. हाँ. यस. सो इलेक्ट्रॉन्स, if electrons are brought in, then this body gets negatively charged, or we can say the body is electron rich. Are you able to get me or not? Is that clear? Okay, so these are the property of charges. Now next thing is, what is the, this is how the charging is done. Next point about the charge is that like charges attract each other. Sorry, like charges repel each other while uh, opposite charges, yeah, that means the charges appears to have two different properties, isn't it? If they are same, they will repel. If they are different, then they will attract, isn't it? But it is totally different from masses, isn't it? Masses always, any two masses will always attract each other. या ठीक है, मास कभी भी रिपेल नहीं करेगा, मास क्या करेगा, मतलब एक दूसरे को अट्रैक्ट करेगा। नेक्स्ट पॉइंट, तुमने चार्ज को देखा, तो ये जो चार्ज है बेटा, दिस चार्ज इज अ स्केलर क्वांटिटी, इट्स अ क्वांटिटी, रिमेंबर दैट, ओके। And we know that it can be positive, negative, and even zero. Are you able to get me or not? Are you able to get me? Next point, next important thing we need to understand that basically a charge at rest only generates the electric field. मूव करेगा तो इलेक्ट्रिक फील्ड की प्रॉपर्टीज चेंज हो जाती हैं, इज दैट क्लियर और नॉट? सो दैट इज व्हाई वी आर स्टडिंग दिस चैप्टर, व्हाई वी आर स्टडिंग दिस चैप्टर इलेक्ट्रोस्टैट्स, बिकॉज there is a property of the charges at rest, that charges at rest generates the electric field, and that means if there is an electric field, if there is some kind of field, मान लो अगर एक शेर है, ठीक है ना, उसका एक केव होगा खुद का, है ना, है कि नहीं? अब मान लो, अब अगर तुम शेर के सामने जाओगे, उस केव के नियरर जाओगे, तो वो शेर अटैक करेगा या नहीं करेगा? तो इसका मतलब क्या है कि शेर का एक अपना फील्ड है, अगर तुम उसके फील्ड को इंटरप्ट करोगे तो क्या होगा, तुम्हारे ऊपर एक अलग एक्स्ट्रा फोर्स फील होगी। ऐसे ही चार्जेस का भी होता है, चार्जेस का अपना अपना एक फील्ड होता है, उस फील्ड को बोलते हैं अपन इलेक्ट्रिक फील्ड, क्या बोलते हैं उसे अपन? हाँ। तो इसीलिए जो चार्जेस, अब कॉन्सेप्ट ये आता है कि इलेक्ट्रिक फील्ड के बारे में हम डिस्क्रिप्टिव वे में कैसे बात करेंगे। सो व्हेन वी वांट टू टॉक इन डिस्क्रिप्टिव वे, वन थिंग आई नीड टू डू इज आई नीड टू कीप माय चार्जेस टू बी एट रेस्ट, टू टॉक अबाउट मच, टू टॉक अबाउट दैट इन अ मच मोर ग्रेटर सेंस। आर यू एबल टू गेट मी और नॉट? ठीक है। सो the first thing, that the charges at rest only generates the electric field. Second point, what happens when the charges starts to be in motion? So with constant velocity a charge with constant velocity produces both electric and magnetic field, ठीक है। अगर कांस्टेंट वेलोसिटी है चार्ज के पास, तो वो क्या करेगा, इलेक्ट्रिक और मैग्नेटिक फील्ड प्रोड्यूस करेगा, बट हाँ, बट इट विल नॉट रेडिएट एनर्जी, ठीक है, चार्ज से कोई भी एनर्जी बाहर नहीं आएगी। इसलिए ये चार्ज, a charge moving with constant velocity will not be visible to you, right or not? So that is why we accelerate the charge. So a charge means it will not be, it cannot be detected easily, right or not? So a charge with acceleration produces both yeah, both electric and magnetic field, and also radiates some energy. So this is the difference between the charge moving at rest, charge moving with constant velocity and charge accelerating with each other. So this is why the first chapter, the first two chapters deals with this property. Third and fourth chapter starts to deal with this property. Word or not? Got it. And fourth, fifth, and all other chapters deals with this kind of property. So this is why the whole first volume of the book, physics of class 12 is divided on the charges at rest, charges at constant velocity, and charges with acceleration. Are you able to get me or not? Is that clear? This is why you will see in the end you are getting a chapter called as electromagnetic waves, and this is what is going to happen. Like the charges at rest generates electric field. Charges at motion generates magnetic field and electric field. Charges with acceleration generates electric field, magnetic field, and with that also some waves. Are you able to get me or not? So this is how whole your whole physics has been divided. First two chapters of NCRT deals with charges to be at rest. Then third and fourth deals with charges having constant velocity. And then sixth and seventh, not fifth, include fifth in this over here. Third, fourth, and fifth. Sixth and seventh of NCRT deals with this charges with acceleration. Is this clear or not? So this is what is the essence of movement of charges or the speed of charges. Is that clear? Okay, can we move ahead? Now let us come to the most important thing, and which we call it as conductors and insulators. We just have a quick recap, then till that I'll drink some water, okay? Yes. Now, any kind of doubt till now? Can I move ahead? Okay, so now look over here. Coming to the next point, conductors and insulators. Now, the question arises that what is conductors and what is insulators? Okay. So basically we call this whole chapter as electrostatic theory. Okay. So electrostatic theory says, sir, one point is there. There are two things in nature. One thing in which the charges can move. One thing in which charges cannot move. Are you able to get me or not? And based upon that, we divide the materials. One we call it as conductors, one we call it as insulators. So, what is our conductors? Basically, conductors are those objects, okay, in which electrons are free to move from one place to another. Okay, while insulators are those objects in which electrons cannot move, okay, or you can say electrons are tightly bound such that they cannot move from one place to another. Okay, is that clear or not? Now the question arises that is this these are only the two properties, isn't it? So these are not only the two properties. This is just the basic property which you have got to understand. Why or not? The main properties of conductors and insulators which are there is actually understood now in much more descriptive way, which we are going to do right now. Okay. So that was मतलब अभी जो बताया वो that was just an जो बोलते हैं ना कि निब्बास का concept था निब्बास no not general, it was just the concept of nibbas. Let us understand actual concept of conductors and insulators. Okay, what are actually the conductors? Let's suppose if I have a body, a conducting body, got it or not? So what will happen if it is a conductor? Then let's suppose if I charge it, got it or not? So बोला जाता है कि if any charge is 1 minute, I think I'll have to use thick pen because thin pen is itself not visible to me. So बोलता है कि if a charge is given to a conductor, then that charge or then it comes to the surface of the conductor due to mutual repulsion. Take, we got to know about charging, isn't it? Right now, we just got to know about charging or not, that we can give or take electrons and the positive and negative charges will appear, isn't it? Now, this positive and negative charges does not suddenly appears. They have a property to be appeared over here. What is that first property? That if it is a conductor and if you charge it or if you discharge it, whatever is there, then the charges will appear on the surface. They will not be present inside this internal region. Are you able to get me or not? So charge inside the region. Okay, charge inside a conductor is always equal to how much? Zero. Well, the charge will इनसाइड मतलब सरफेस को छोड़ के, जैसे मान लो सॉलिड स्फेयर है तो एक सरफेस होगा, सरफेस के अंदर भी तो ऑब्जेक्ट्स है ना, सरफेस के अंदर भी तो मटेरियल है ना, तो उस मटेरियल में कोई भी चार्ज प्रेजेंट नहीं रहेगा. आर यू एबल टू गेट मी और नॉट? ओके, नेक्स्ट पॉइंट इज these charges these charges appears on the surface such that on the surface of conductor such that their density varies inversely proportional to distance from center. Take, are you able to get me or not? How it is going to vary? Inversely proportional to the distance from center. Remember that. So always remember that this is one of the biggest property. What is the meaning of that? That if a conductor is there, it will regain these charges on the surface only in such a way that their density starts to vary with respect to the distance from the center. Are you able to get me or not? Is that clear? Got it. And that is why we call it we specifically we define this particular, just like earlier in physics we defined surface mass density and all. So this density we call it as surface charge density. Okay, so conductor poses surface charge density, which we define it as sigma, and sigma is inversely proportional to always 1 by r. Okay, is that clear or not? Is that clear? Next thing, next let us talk about insulators. What are the insulators? So let's suppose if I have any kind of a body, ठीक, जैसे मान लो ये एक बॉडी हो गया है ना, तो इंसुलेटर्स में क्या होता है उसके बारे में समझते हैं। बोलता है कि these are those kind of bodies, means you can say that whenever I give the charges, what will happen? These charges will redistribute, word or not. Let's suppose if I charge, so लिख लेता हूँ, if a charge is given to an insulator, then the charges it gets evenly distributed along the whole body. क्या हुआ इसमें कि अगर मान लो इंसुलेटर है और इंसुलेटर के ऊपर तुमने चार्ज दिया, तो इंसुलेटर में चार्ज जो है कि उसमें ऐसा नहीं होगा सिर्फ सरफेस पे ही प्रेजेंट है, उसमें सरफेस पे ही सिर्फ नहीं प्रेजेंट रहेगा, उसमें इस तरह से चार्ज प्रेजेंट रहेगा कि वो इवनली डिस्ट्रीब्यूट हो जाए। कैसा डिस्ट्रीब्यूशन हो इसका? Evenly distribution. Are you able to get me or not? Here density used to vary, but here density remains constant. Density tries to remain constant. Are you able to get me or not? And that's the biggest difference between a conductor and a insulator. Is that clear? Is unclear totally? Got it or not? So let's suppose that, like, let's suppose if I have a hollow body, hollow conductor or an insulator, means remember that for a hollow conducting or insulator body everything is same, means the charges will appear on the surface since there is no internal material. So whether it is an insulator or whether it is a conductor, the charges will be evenly distributed on the surface. Are you able to get me or not? So conductors and insulators behave exactly same for which kind of a body? Hollow objects. For which hollow bodies have are similar, are having similar properties of conducting and conductors, similar लिख लो, similar properties of conductors and insulators. Is that clear or not? Is this totally clear? मजा आया concept समझ के? What is the biggest difference between a conductor and an insulator? Okay, so let us just have a one question regarding this, isn't it? So let's suppose if a body is given in such a form, one minute, sorry, we just uh, okay, so this is my body and this body is provided some charge. This is a conductor, okay, and this is point A, this is point B, and this is point C. Question is, tell me where the surface charge density, if it is a conducting body, then the options are option A, sigma at A is equal to sigma at B is equal to sigma at C. Option B, sigma at A is more than sigma at B is more than sigma at C. Option C, sigma at A is less than sigma at B is less than sigma at C. Option D, none of these. Which of these are correct? Tell me. If it is a conducting bond. No. Acha, is it a symmetrical body or non-symmetrical? It's a non-symmetrical body. Yeah. So to understand in a much more greater concept about a non-symmetrical body, what you need to do? You need to draw a circle over there, isn't it? Like this way. You need to draw a circle over there now. And then on this circle, you need to draw the radiuses. To know about the radius of curvature, see, we have given that the charge density varies with respect to what? Radius or not. So what we have to do, if whether it is a, yeah, so it's not a symmetrical body. So what you need to do? You need to draw the circle at those 3 points. Then check the radiuses. What you are going to observe? So radius at A is less than radius at B is less than radius at C, isn't it? So sigma is inversely proportional to that. That means sigma at A is more than sigma at B is more than sigma at C. Which option is correct? Option B. Right or not? Is that clear? Then you do not have to consider symmetrical body means what? It will have a constant sigma. Okay. If it is a symmetrical body, then you can have both also, no problem. If it is a symmetrical body and if it is a conductor, then sigma is same for all points. Yeah, is this clear or not? Understood? Yeah. No, no, no. Insulator can have a different densities. Insulate. What is there in insulators? There is charges which are appearing at the inside region also or not. So you have to talk about insulator in a different way. Insulators will have a totally different property because it has some charges at the inside region also. So density, you can't say that density is always constant for insulators. Okay, density can also vary also, constant or you can say also vary. We can make it vary, no problem regarding that. Okay, but if it is charged, it will be distributed in such a way that it is going to be constant. We can make the density by ourselves to be varying. Okay, I don't know. But when it is charging, then the density will remain constant. Here we are talking about case of, here we are just taking a random case that fully symmetrical body. तुम खुद सोचो, मतलब एक बात, सिमेट्रिकल बॉडी है, इंसुलेटर है, तुमने चार्ज दिया, इक्वली डिस्ट्रीब्यूट हुआ है ना. लेकिन लेकिन ऐसा तो हो सकता है ना कि मान लो हम ऐसा भी तो कर सकते हैं ना इस सिमेट्रिकल बॉडी के अंदर क्या किए कि डेंसिटी पहले अंदर में थोड़ा कम रखें, बाहर में थोड़ा सा ज्यादा, थोड़ा और ज्यादा, ऐसे करके डेंसिटी को ही हमने बढ़ा दिया है कि नहीं. तो फिर तो ये नॉन यूनिफॉर्म डिस्ट्रीब्यूशन हुआ या नहीं हुआ. So if you charge it, then it is going to be uniform distribution, constant distribution. But when you can vary, it can be also varied with respect to you. Right or not? Is that clear? Understood? Yeah, constant. Can we move ahead? Okay, now let us move to the next point. And that is, now as we know that we can charge the body, like we can put some charges on the surface or inside regions also. So there are three kinds of charging. Okay, so give the heading methods of charging. Okay, so we have the first one, we call it as conduction. Okay, second process we call it as induction, and third process we call it as friction. Hold on. There are three ways in which you can charge a body. One is conduction, second one is uh, induction, third one is friction. So we'll start with the first one, which we call it as conduction. Now, what is the property? Like how, if you are going to charge a body, then the first method, which we call it as conduction, इसका मतलब होता है कि I'll try to bring the charges on each other, but there is a way to do it, and the way is, in this the physical contact is required. क्या चीज की रिक्वायरमेंट है? Yeah. So the first process, which we call it as conduction, and in the conduction, what we are going to require is a physical contact. Are you able to get me out? So let's suppose if I have two bodies, heard or not? ठीक. So मान लो ये दो बॉडीज थे, है ना? अब मान लो इसके ऊपर कोई चार्ज पहले Q1 था, इसके ऊपर चार्ज कितना था? Q2, है ना? तुम क्या किए, इन दोनों बॉडीज को आमने सामने लाए, कांटेक्ट में लेकर आए। तो जब कांटेक्ट में लेकर आओगे तो दोनों बॉडीज के ऊपर क्या हो जाएगा, टोटल चार्ज आ जाएगा, Q1 प्लस Q2 आ जाएगा ना? यस, इसके ऊपर क्या आ गया, Q1 प्लस Q2। अब जब तुम इनको दोबारा से सेपरेट करोगे, है ना, पहले ब्रॉट टुगेदर, सो चार्ज गॉट एडेड। अब होगा क्या कि जैसे ही तुमने इनको दोबारा से कंडक्शन के बाद सेपरेट किया ना, तो इन दोनों बॉडीज के ऊपर जो चार्जेस आएंगे वो इस तरह से चार्जेस आएंगे कि इसके बाद में जो होगा वो इक्वल डिस्ट्रीब्यूशन ऑफ चार्जेस होगा। कैसा होगा डिस्ट्रीब्यूशन? राइट और हरदम तो चार्ज का इक्वल डिस्ट्रीब्यूशन होना चाहिए ना। तो इसके ऊपर जो चार्ज आता है वो आता है Q1 प्लस Q2 डिवाइड बाई 2, और इसके ऊपर भी चार्ज आता है Q1 प्लस Q2 डिवाइड बाई मीन चार्ज विधान से equal distribution should be there, always equal distribution I should say. Yeah, got it. Is that clear? So whenever you have means, we can say that this is how the process of conduction works, that we can charge the one body or another body. Let's suppose if it would have been even a neutral charge, then this body would have got some charge over there. So this process involves two things. One is physical contact. Okay. And second thing is the equal distribution of charges during separation. Word or not? Is that clear? Okay, can we move ahead? Okay, so now look over here. Try to do this question. Okay, बोल रहा है there are three different bodies. Well, let me just delete it. Okay, I have three different bodies. Wait a minute. And this is body A, body B, and body C. This one is having 4 coulomb. This one is having 0 coulomb right now, and this one is having 3 coulomb. So you see the step. First step is A and B are touched. Sorry, and separated. Second step is after that B and C are touched and separated. Third step is A and C are touched last. Okay, and separated. Remember that these all are happening in sequence. Okay. Hello, can you hear me? So first, after that second, after that third. Okay. Then question is find the final charges on ABC. Find the final charges on, yeah. No, final charges. Finally, what I'm going to get on A, B, and C. Okay? Yeah. बताओ, what will be the answer? Two different values. Two different values you will not get. Finally, you will get a one answer. You have the three different cases, but those three are totally different. You see the sequence. First A and B are going to be touched together. The first step, isn't it? So initially A has 4 coulomb, this one is having 0 coulomb, isn't it? Huh. So this one after the separation means after first they are touched and then separated, then what will happen? A will have 2 coulombs and B will also have 2 coulombs in the first case, isn't it? Now B and C are touched together. B and C, the second step. Then once again they will be separated. So 3 plus 2 is 5. Then this will have 2.5 coulombs. And C will have after separation how much? 2.5 coulombs, isn't it? Now A was there with 2 coulombs, CU is there with 2.5 coulombs. Now they are once again touched together in the third sequence, isn't it? When you touch together in the third sequence, once again A and C will be separated. And A and C will how many? 4.5 divided by 2, that is 2.25. And this one will have also 2.25. So how much is the charges left on A, B and C? So A is having after all these sequences 2.25 coulomb, B is having 2.5 coulombs, C is having 2.25 coulombs. That's your answer. Is that clear? Yeah. So you have to repeat all these processes. Okay. You have to definitely repeat all these processes, and that will provide you the answer. Is that clear or not? Hmm. Can we move ahead? Okay, so अब ध्यान से देखो, let us move to next point. Now we got to know about all these things, all these cases. Okay, now, so this was the process which we call it as conduction. Next process which we have, we call it as induction, isn't it? So let us talk about this in a great sense. Let us talk about this. Okay, now what is induction? So, see, in conduction, what used to happen in after the physical contact, there used to be a redistribution, isn't it? Similarly, here also there is a redistribution of charge. Okay, but without any physical contact. But without any physical contact. Are you able to get me or not? Uh, is that clear? Now, if there is a redistribution of charge without any physical contact, one thing is very, very peculiar to note over here, that okay, whatever is my whatever is the initial charge on the body, that remains always same. Yeah. After redistribution also, that remains same. Are you able to get me or not? Okay, so let's suppose if I have any neutral conductor. Okay, this is my a neutral conductor. So in neutral conductor, you can see that it will have both positive and negative charges, isn't it? It will have both positive and negative charges. है कि नहीं? This is my neutral conductor, isn't it? Now, sorry, I have just redistributed. I can't say like that. This is the last step. So if it is a neutral conductor, let's suppose if I have this as neutral conductor, then it will have both positive and negative charges, whatever is that, कुछ भी हो, तो ये हरदम ऐसे ही रहेगा, as it is रहेगा, okay, है ना? ठीक है. तो इसके ऊपर चार्ज ऐसे ही पड़ा हुआ है, कुछ मतलब नहीं है ना. लेकिन जैसे मान लो तुमने क्या किया, इसके सामने एक प्लस चार्ज ला दिया. क्या ला दिया? अब इसके बीच में कोई कांटेक्ट नहीं है अपने पास. देयर इज नो कांटेक्ट बिटवीन देम, राइट और नो? नाउ although there is no contact, you can see that if there is still no contact, what can happen? There is no contact over here between this sphere and this plus charge. But बिना कांटेक्ट के भी ये बॉडी क्या करेगा, यहां से नेगेटिव चार्जेस को अट्रैक्ट करेगा, है कि नहीं? हम्म. और जब नेगेटिव चार्जेस आ जाएंगे तो पॉजिटिव चार्जेस क्या करेंगे? पॉजिटिव चार्जेस पीछे की ओर, इधर की ओर अपने आप ट्रैवल करने लगेंगे, है कि नहीं? तो ध्यान से देखो. हाँ, तो हुआ क्या एक्चुअली में, दैट आफ्टर ब्रिंगिंग दिस चार्ज ये अट्रैक्शन की वजह से इधर नेगेटिव चार्ज शिफ्ट हो गया, इधर कौन सा चार्ज शिफ्ट हो गया, पॉजिटिव चार्ज, और इसी प्रोसेस को बोला गया इंडक्शन। इस प्रोसेस का नाम क्या दिया गया, इंडक्शन। लेकिन ध्यान से देखो तो अभी भी फाइनली आफ्टर द इंडक्शन टोटल चार्ज इस सरफेस के ऊपर कितना है, जीरो है ना। अगर सारे पॉजिटिव सारे नेगेटिव को ऐड कर दूं तो कितना है, जीरो। हाँ, तो जो भी इनिशियल है उतना ही, या सो जो भी इनिशियल है उतना ही फाइनल है आफ्टर द इंडक्शन आल्सो। दैट्स व्हाट दिस स्टेटमेंट मींस, व्हेनेवर देयर इज अ इनिशियल चार्ज दैट रिमेन्स सेम इन द प्रोसेस ऑफ induction. Are you able to get me? Is that clear? Same as, yeah. So initially it has zero, बाद में भी क्या हो जाएगा, जीरो, है कि नहीं। अच्छा, अब मान लो इसी बॉडी के साथ मैं क्या किया कि इस बॉडी के ऊपर एक और बॉडी को कंडक्ट करा। तो इंडक्शन समझ में आया ना, इंडक्शन इज अ प्रोसेस इन विच व्हाट विल हैपन कि जो भी चार्जेस हैं वो अपीयर होंगे, जो इनिशियल चार्जेस वो रिडिस्ट्रीब्यूट होंगे, है ना। किस तरह से, इन सच अ वे दैट वन साइड इट हैज नेगेटिव and one side it has positive, and which makes still the total charge to be equal to how much, zero. Are you able to get me or not? So that means we can say that after induction also the body is a neutral conductor. Got it or not? So induction does not makes anything. Induction does not brings extra charges. Just like in previous case with the help of conduction, we have some charges on the bodies. In induction, there is no extra charges on the body. Are you able to get me or not? Yeah. What if there is a question on YouTube that what if two charges are present on either side? Then also there will be a redistribution. Like if you'll come to the capacitance, there will be term actually. There is in when we will come on the capacitance chapter, then this thing will appear. We have a dielectric slab and then we have two different plates with two different charges. ओके, तो वहां पर हम देखेंगे कि प्लस क्यू की वजह से डोमिनेट जो हो रहा है, जो पहले से डिफाइन हो गया। तुम ध्यान से देखो, जैसे मान लो ये प्लस क्यू और इधर माइनस क्यू है, तो इधर क्या आ जाएगा, फिर से माइनस आ जाएगा और इस साइड क्या होगा, प्लस, विच एक्चुअली मैचेस विथ नेगेटिव। बट इफ आई हैव सेम चार्जेस then there is a chance that no induction will take place. Are you able to get me or not? Is that clear? So if on the two different sides, if we have opposite charges, the induction is stronger. But if I have same charges on the two different sides, then the induction is very less. Are you able to get me or not? Is that clear? But the redistribution can happen. Okay. Now, after the induction, अब हम क्या करना चाह रहे हैं? Let's suppose what we do is we bring this body, which is a neutral conductor, and made a contact with this bigger sphere. Right or not? अब जैसे ही इस बिगर, या तो जैसे ही हमने इसको पॉजिटिव साइड की ओर कांटेक्ट करवाया, इस स्फीयर के ऊपर सम पॉजिटिव चार्जेस आ जाएंगे, है कि नहीं? Isn't that some positive charges will appear? Are you able to get me or not? Is that clear? So this is how the process occurs. Means अगर मान लो तुम्हारे पास, अगर प्योरली अगर कोई कंडक्टर है, इसके सामने अगर प्लस क्यू रखे, इधर भी प्लस क्यू रखे, तो रीडिस्ट्रीब्यूशन कुछ इस तरह से होगा विच विल बी नेग्लेजिबल, ऑलमोस्ट नेग्लेजिबल। बट अगर मान लो गलती से तुमने इसको क्या कर दिया, माइनस चार्ज कर दिया, तो माइनस चार्ज को तो प्लस चार्ज ही चाहिए ना इस साइड, और प्लस चार्ज को कौन सा चार्ज चाहिए, माइनस चार्ज चाहिए। तो रीडिस्ट्रीब्यूशन विल बी मच मोर स्ट्रॉन्ग। आर एबल टू गेट मी और नॉट? Induction is also stronger. Is that clear? Now, next point is very simple, that with the help of induction also I can have a conduction। कि हमने अगर मान लो एक अनदर न्यूट्रली चार्ज बॉडी लेकर आए, अगर उसको पॉजिटिव चार्ज की तरफ कांटेक्ट करवाएं, तो फिर क्या कौन सी चार्जेस उसके ऊपर आएंगी, पॉजिटिव चार्जेस। इज दैट क्लियर और नॉट? इज दैट क्लियर? ठीक। सेकेंड पॉइंट है, एक और पॉइंट अच्छे से समझने की जरूरत है कि मान लो सर, अगर आपने इस बॉडी के सामने, अभी तो आपने बहुत अच्छे से समझाया, एक और पॉइंट रखते हैं। अगर मान लो इस बॉडी के सामने आपने प्लस क्यू रखा हुआ है, ठीक है, और इसके ऊपर पॉजिटिव चार्जेस है ना। अब ध्यान से देखो, व्हाई इंडक्शन इज वेरी इफेक्टिव मेथड विल से, तो हमें मालूम है कि इधर नेगेटिव चार्ज आ जाएंगे, इधर पॉजिटिव चार्ज आ जाएंगे. इज दिस क्लियर? Now, what I do is I just take this body and then I connect this body with the ground. Okay. Now, this is the first thing, this is the first time you might be hearing this word, that connecting with the ground. ठीक है है ना. इस ग्राउंड को हम लोग अर्थिंग के भी नाम से जानते हैं. ठीक है. Why we brought this concept of earthing, I'll tell you. So, अपन के पास दो तरह के प्रोसेस हैं चार्जिंग करने के. एक तो है सर कंडक्शन और दूसरा है इंडक्शन. थर्ड प्रोसेस, दूसरा प्रोसेस है डिस्चार्जिंग का, बाय ब्रिंगिंग अनदर न्यूट्रल बॉडी एंड मेकिंग इन कांटेक्ट विद द अदर बॉडी. एंड द अनदर प्रोसेस ऑफ डिस्चार्जिंग वी कॉल इट एज इज अर्थिंग. आर यू एबल टू गेट मी और नॉट? सो व्हाट डज अर्थिंग डज? Remember that earthing attracts, earthing tries, means earthing is that point. मेरे पढ़ाने का तरीका बड़ा कैजुअल है. अरे 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 ठीक है, थोड़ा कैजुअल और अच्छे से कर लेंगे, टेंशन ना लो. तो पॉइंट है कि अर्थिंग क्या करता है. अर्थिंग पहले तो ये सारे पॉजिटिव चार्जेस को खा जाता है. ठीक है ना. इट इट्स अप, इट इट्स पॉजिटिव चार्जेस. रिमेंबर दैट. आर यू एबल टू गेट मी और नॉट? अर्थिंग क्या करेगा, सारे पॉजिटिव चार्जेस को खा जाएगा. तो ये जितने सारे पॉजिटिव चार्जेस हैं वो सारे के सारे क्या हो जाएंगे, अर्थिंग के अंदर चले जाएंगे. और एबल टू गेट मी और नॉट? तो बचेगा इस बॉडी के ऊपर कौन सा चार्ज, प्योरली नेगेटिव चार्ज. और ये जो कंडक्टर न्यूट्रल कंडक्टर था उसको हमने क्या बना दिया अभी, प्योरली नेगेटिव बना दिया है. Right or not? So this is how a charging is also done. Means instead of bringing the electrons or instead of bringing something, we can itself make a huge ball of a negative charge. कैसे? तो सबसे पहले एक पॉजिटिव चार्ज लाएंगे छोटा अमाउंट का, उसकी वजह से रीडिस्ट्रीब्यूशन होगा. रीडिस्ट्रीब्यूशन में क्या करो, अर्थिंग लगा दो. अर्थिंग लगा देने से पॉजिटिव चार्जेस सारे के सारे क्या हो जाएंगे, नेग्लेजिबल. और बॉडी पूरा का पूरा क्या बन जाएगा, नेगेटिवली चार्ज बॉडी. इज दैट क्लियर और नॉट? So these are the processes which are there with the means we can have. Similarly, what? हाँ हाँ. No, no, earthing will never ever eat up the negative charge because earthing is a point of, you can say that zero value, right on. So it will not eat the negative values. It will only eat up the positive value which can be brought to zero. Are you able to get me or not? You can see like negative values. Yeah. नहीं, नेगेटिव चार्जेस को कुछ नहीं होगा. ओके, इज दैट क्लियर? So this is what is the process of charging and discharging, how the charges and redistribution occurs. The first thing is conduction, where the redistribution is in equal way. Second process is induction, and third process is called as earthing, which we definitely bring it to reduce the positive charges into zero. Can we also create a positive one? Creation of a positive one is different. Means what we can have the positive one like this way. Like if I have the sphere, I'll connect with the positive side. So positive charges will appear, but that will be of less amount. That will not be of significant amount. Are you able to get me or not? Okay. So this is how we generate the positive charge and negative charge in an abundant way. Is that clear? Okay. Now, let us see how the induction actually is there. So, induction is present in many forms. The one of the most peculiar form is induction in atoms. Okay, go ahead. Yeah. So, we'll see the first process how the induction is there. तो ध्यान से देखो. तो सबसे पहला process है induction in atoms. What actually happens? Let's suppose if we have any atom. Okay. Which one is having some nucleus, so this is the nucleus of this atom. Okay, and then there is electron cloud over it, isn't it? है कि नहीं? ये न्यूक्लियस है जिसके अंदर कौन से चार्जेस हैं? पॉजिटिव चार्जेस। और इसके बाहर क्या है? इलेक्ट्रॉन क्लाउड है। इलेक्ट्रॉन क्लाउड में क्या होगा? हाँ, इलेक्ट्रॉन्स आर लाइक दिस वे, सॉरी, okay, electrons are revolving. So this is my atom configuration, we call this is electron cloud. Okay, अब मान लो अगर तुम इसके सामने कोई पॉजिटिव चार्ज लेकर आते हो, ठीक है ना? ठीक, जैसे मान लो ये इलेक्ट्रॉन क्लाउड हो गया, इसके सामने तुमने क्या किया, एक प्लस चार्ज लेकर आया, ब्रिंग इट इन। सो जैसे ही तुमने इसको लाया, क्या हो जाएगा? ये इलेक्ट्रॉन क्लाउड पूरा का पूरा क्या हो जाता है? शिफ्ट हो जाता है टुवर्ड्स द पॉजिटिव चार्ज। आर एबल टू गेट मी और नॉट? Got it. This whole electron cloud gets shifted towards the positive charge, and this is how the bond formation happens. Got it or not? Yeah. So the induction is the that particular process which helps us in understanding all these kind of conditions. Are you able to get me? And this process in which the electron cloud get attracted towards the positive charge, we call this process as polarization. क्या बोलते हैं इस process को? Got it or not? Is that clear? And there is a we are going to talk a lot about polarization, got it or not? So this polarization uh, actually helps us to bring so many charges on the surfaces of the conductors and insulators, mainly on insulators, which further helps in storing the charges, and got it or not? Okay, so this particular kind of polarization is represented in this fashion. Okay, this is negative and this is positive, and we represent like this way. Got it or not? So this is how polarization is represented, or induction in atoms is represented. Is that clear? Got it. Can we move ahead? Now, so we got to know about induction, we got to know about conduction. Then we have third part or third process of charging, and we call it as friction, isn't it? So let us talk about this. One of the most important category of charging, we call it as friction, or by the friction. Are you able to get me or not? So what actually happens? What is actually happening? What is going to happen due to friction? So you know that due to friction, what actually happens? Can you tell me? We know that heat gets developed. First process, heat गर्म हो जाती है। हाँ, गर्म हो जाती है चीजें, है ना? Isn't it? Loss of too much physics is there. I can't understand that much of physics. So due to friction, first thing is heat develops, isn't it? Okay, and after that, if after that heat develops, then the next process starts, that इसके वजह से तुम्हें मालूम है, मान लो अगर क्लब में पार्टी हो रही है, तो भाई ने अगर किसी ने चढ़ा ली, तो वो क्या होता है, उसके अंदर एनर्जी अचानक से बढ़ जाती है। वैसे ही होता है, फ्रिक्शन क्या करता है? फ्रिक्शन इलेक्ट्रॉन्स को एक्साइट करता है। सो ड्यू टू फ्रिक्शन हीट डेवलप्स एंड देन इलेक्ट्रॉन्स गेट्स एक्साइटेड, गॉट और नॉट? ओके, हाय बट बेतिसा, गुड इवनिंग। सो इलेक्ट्रॉन्स गेट्स एक्साइटेड, ठीक है। अरे यार संजय पढ़ाने तो यार। संजय ने लिखा है सर फ्रिक्शन से पैंट फट जाती है। अरे फ्रिक्शन तुम नीचे रगड़ोगे तो पैंट फटेगी ही ना भाई, ठीक है। सो ड्यू टू फ्रिक्शन हीट डेवलप्स, फिर उसके बाद इलेक्ट्रॉन्स गेट एक्साइटेड एंड दे स्टार्ट टू अपीयर ऑन द सरफेस, appear on the surface of the body. ठीक है. So what actually happens that when we have the heat developed over there, electrons are going to get excited and then they start to appear on the surface of the body. Now what is going to happen? अब तुम खुद सोचो, मान लो एक बॉडी ए है, एक बॉडी बी है और एक बॉडी ए है ना. ठीक है ना. अब इन दोनों के ऊपर फ्रिक्शन लग रहा है, जैसे ही फ्रिक्शन बढ़ रहा है इन दोनों के ऊपर चार्जेस आ रहे हैं, है ना. एक के ऊपर कुछ ना कुछ चार्ज होगा, एक के ऊपर दूसरा कोई चार्ज होगा, है कि नहीं. अब दोनों बॉडी में क्या आया, दोनों बॉडी के ऊपर यहाँ पर इलेक्ट्रॉन्स आए, है ना, सरफेस के ऊपर. ऐसा तो नहीं होगा कि सिर्फ एक बॉडी में होगा, नहीं. ऑन बोथ द बॉडीज यू विल गेट द इलेक्ट्रॉन्स ऑन द surface, isn't it? The question is very simple. That sir, if the electrons are appearing, same charges are appearing, then how the transfer will happen? We know that until and unless there is a transfer, we can't say there is a process of conduction or charging has happened, isn't it? So there should be a transfer of these charges, isn't it? So question is how the transfer of these charges happens, isn't it? So can you tell me that what is the necessary condition that this body should pose such that the transfer of charges will happen during friction? ठीक है. I'll explain this. देखो मैं explain ही कर देता हूँ, actually ये जल्दी किसी को पता नहीं है. अब तुमने समझा, हमने क्या किया, दो बॉडीज को रब किया, है ना. I just rubbed two bodies together. I'll take this two objects. So I have these two bodies and I'm just rubbing them together, isn't it? This is body A and this is body B. Now electrons appear on the surfaces of the body. Now the point is these electrons needs to transfer from one body to another body. Otherwise, if these electrons will not transfer, the process of charging will not happen, isn't it? So how the electrons will transfer? There is a necessary condition of there is a necessary condition which is applied over there. What is that necessary condition? That the electrons are pulled by the body which is more electronegative. Yeah, which is more electronegative. Word or not? So द पॉइंट इज वेरी वेरी सिंपल. तुमने इलेक्ट्रॉन लाया, अरे ये इलेक्ट्रॉन को तो अट्रैक्ट करने वाला चाहिए ना. अपने पास दो तरह के आइटम्स होते हैं, एक होते हैं इलेक्ट्रो पॉजिटिव और दूसरा होता है इलेक्ट्रो नेगेटिव, है कि नहीं. इलेक्ट्रो पॉजिटिव कौन से होते हैं? इलेक्ट्रो पॉजिटिव आर दोज एटम्स व्हिच हैव एक्स्ट्रा इलेक्ट्रॉन्स, वर्ड और नॉट, ओके. एंड इलेक्ट्रो नेगेटिव आर दोज एटम्स व्हिच हैव लेस इलेक्ट्रॉन्स. ऑपोजिट इज देयर. या सो या Yeah, so we have to say opposite way. Electropositive is that which has less number of electrons, word or not? Sorry, more number of electrons. Well, electronegative is that which has less number of electrons. Are you able to get me or not? So the point is these electrons, wherever these electrons are getting present, means जब जैसे ही electrons बाहर आ गए surface पे, तो एक body इसमें सबसे important condition ये होनी चाहिए कि जो one of the body should be always electronegative in nature, right or not? Electronegative, then only it will attract these electrons. Means if it is electronegative, then what it will have basically, it will not have electrons on the surfaces. Since it is electron deficient body, it will be basically having positive charges to show up over here. Are you able to get me or not? After what? Yeah. So electronegative, no, no, actually, who knows, on YouTube there is a comment that electropositive attracts. No, you have to see in chemistry there is a difference between the electropositive and electronegative, got it or not? Okay, so the electropositive are those which will have, you can say, more electrons over there. Yeah, got it or not? So electrons are pulled by the body which is more electronegative in nature, that we need to remember. Is that clear or not? Okay. Is this clear? Now, the point is, which are more electronegative in nature? The question arises that which are basically, you can see that electronegative are those atoms which are going to be called as insulators. Now, acha, tum log ko, I think there is a confusion you might be understanding that why I have taken the electropositive and electronegative name. You see that, acha, ek baat batao, we call sodium as electropositive, isn't it? And we call it chlorine as electronegative, isn't it? Why we call it as electropositive and why we call it as electronegative? Sodium has electronic configuration 281 and it has electronic configuration 87. So look over here, Na actually donates the electron, isn't it? हाँ, तो ये क्या है, donates the electron मतलब क्या, इलेक्ट्रॉन, एक्स्ट्रा इलेक्ट्रॉन, means abundance of electrons is there in that atom or not, and that is why it is electropositive. So remember, electropositive is electron rich. Okay, while electronegative is that electron deficient, because it actually accepts one electron to complete its octet. Okay, so my point was regarding this way, that what is electron deficient and what is electron positive. Is that clear or not? Now you got it. Is this clear? So this is how the point is taken for the electron deficient atoms and electropositive atoms. Are you able to get me or not? Is this clear? Okay. Now, so this is why I said that electrons are pulled by the bodies which are more electronegative in nature, because these electronegative are only which are going to take over the electrons. Are you able to get me or not? So in friction, during the friction, when we rub the body, one necessary condition is one of the bodies should be electronegative in nature, because it needs to accept the electrons which are going to be present on the surfaces. And this means one thing, that electronegative character is possessed by only the elements which are insulators in the periodic table, isn't it? So the most Yeah, so the most important condition to have charging of the body through the friction is at least one of the body should be an insulator. At least one of the body should be a insulator. And this is how the process of charging happens with respect to friction. Is this clear on YouTube, guys? मजा आया? Concept समझ में आया? How one is called as electronegative and why one is called as electropositive. Electropositive means electron rich, which can donate the electron. Electronegative means electron deficient, which can accept the electron. Are you able to get me or not? Is that clear? And that is why electropositive character is posed by metals, while electronegative character is possessed by insulators. And that is why during the case of friction, we require one of the elements or one of the materials to be insulator, such that it can accept the electrons which are appearing on the surfaces over there. Is that clear or not? Now, we got to see that what is happening, that these charges are trying to attract or repel these charges, isn't it? When one charge is brought nearer to another charge, we can see that it is trying to attract or repel the charges. And the concept to understand the better essence of this, or to talk about that in a much more greater sense, the person who talked about this attraction and repulsion was the scientist Coulomb. And right now we are going to start that only, to discuss about Coulomb's law. Till that, if you have any kind of doubt, you ask me, okay? Mm-hmm. Any kind of conductors are electropositive, yes, definitely conductors are electropositive, electron rich. That's why free electrons are found in conductors only. Is that okay? So let us bring the concept of one of the most important topic, which we call it as Coulomb's law. Heard or not? So what is Coulomb's law? We know that whenever, what does it say? When two electric charges are placed, when two electric charges are placed at some distance from each other, basically a force acts between them. One minute. हेलो. हाँ शिव सर. अच्छा आप आ गए हैं क्या? 1 minute, 1 minute. I'm in the room. Can you just come up with 10 minutes? Okay, 1 minute system. Sorry for delay. Yeah. Okay, so where I was? Yeah. So when I have two electric charges which are going to be, like, let's suppose if I place two electric charges so at some distances from each other, word or not, so we got to know that some kind of a force acts between them, isn't it? Okay. The point is very simple regarding that. That this force can be attractive, this force can be also repulsive, word or not. Now, when it is attractive, when it is repulsive, that depends on the points. Let us see. So let's suppose if I have the charge one as Q1, another charge I have as Q2, T, and they have a distance gap of some distance D between them. Got it? Some distance gap is there. Okay. Uh, let us use the normal sign convention. Let us call the distance gap to be R. तो ध्यान से देखो, बोलता है Coulomb's law कि sir, if these are two charges which are same, means this one is also positive and this one will also positive, we know that the like charges will repel each other. So what will happen, that this q1 charge will try to repel this charge q2, and this q2 will also repel this charge q1, right or not? But there is one more important condition which you need to understand, that this repulsion is only present along the line joining charges. They will not be present over here in this space. These forces are not present in that space. Word or not? These forces are only present along the line joining the charges. The first condition is that. And that is why the one biggest important term is given to this, that these forces are called as also by a name of central forces. क्या बोलते हैं इसे अपन? Word or not? Now, the point is, let's suppose I represent that this force applied by 1 on my 2, and this is my force applied by 2 on my 1. Right or not? This is how I'm writing. Okay, I'm going from right to left. Is that clear or not? The question is, or the point is, that this force is given as the magnitude of these forces are basically equal to each other, but their directions are totally different. Yeah, and they are directly proportional to the magnitude, product of magnitude of the charges, and inversely proportional to one of the distance square between them. Are you able to get me or not? Is that clear? And this is why the Coulomb force is given. It is given as, if I replace this proportional sign, we get a constant which we call it as K. Okay, or we represent it as K. I'll represent it as K, and Q1 Q2 divided by Rs. Are you able to get me or not? Now, what is this K? Let us talk about this K. K is called as electrostatic constant. Okay. What is this K called as? Electrostatic constant. The point is that this K is actually, अब मान लो, तुम ही सोचो, मान लो जैसे क्या हुआ था कि मेरी अभी मतलब वो प्री वेडिंग सेरेमनी थी। तो अब मान लो मैं बाजार में गया, एक ऐसे खुले रोड पे ऐसे फोटो खींच रहा है, एक कैमरामैन हम दोनों की फोटो ले रहा है ना, और एक बाजार में से ऐसे फोटो ले रहा है। कहाँ पर फोटो इजिली एक्सेसिबल है? ओपन रोड में, है कि नहीं? तो अगर तुम्हें ओपन रोड मिला तो फोर्स अप्लाई करने की टेंडेंसी बढ़ जाती है ना। अगर तुम्हें अगर बिजी रोड मिल रहा है तो क्या हो रहा है? फोर्स अप्लाई करने की टेंडेंसी घट जा रही है कि नहीं घट जा रही है? तो एज यू कैन सी, with respect to medium, the condition of applying the forces is changing, and that is why this also changes. Means the force between the charges also depends upon the medium, and that dependency is brought by this constant. Are you able to get me or not? Which we call it as electrostatic constant. Are you able to get me? So this electrostatic constant, it depends on the medium. Yeah, it is dependent on the medium uh, in which, yeah, in which the charges, in which the charges are placed. Take. Is that clear or not? Are you able to get me? Next point. First thing is that, so let us talk about these properties. First thing, that this force present between the charges, मतलब मान लो अगर ये 10 कूलम है और ये 5 कूलम है, तो ऐसा नहीं होगा कि 5 कूलम will apply a less force and 10 कूलम will apply a more force. ऐसा नहीं है. Both of them will apply a same amount of force. Remember that. Both of them are applying. Yeah. So means the force, I'll tell you one thing, the force present between the charges is independent of their respective magnitude, but depends on product of magnitude. मतलब पॉइंट क्या है कि मान लो सर, आप एक काम करो, आप ऐसे चार्जेस सेलेक्ट करो। मान लो ये है 4 कूलम और ये भी चार्ज है 4 कूलम। ये चार्ज है तुम्हारा 8 कूलम और ये चार्ज है 2 coulombs, go ahead or not. ये चार्ज है तुम्हारा 16 coulombs और ये चार्ज है सिर्फ 1 coulomb, while the distance between all of them is still same, go ahead or not. Distance is just distance between their centers, actually I'm drawing, okay. Distance is still same, which is 2 meters, 2 meters, 2 meters. तो ऐसा नहीं है बेटा कि क्या हो रहा है कि this 4 coulomb is applying some force over here and some force over here. This 8 coulomb is applying some force over here and some force over here. This 16 coulomb is applying some force over here and some force over here. So the point is, if you see that the product of the force over here in all of these cases is just 16 coulombs, isn't it? If you take out the product Q1 into Q2, it is exactly equal to how much? 16 coulombs. That means that whatever this 4 coulomb is applying, let's suppose this is force 1, this is force 1, this is force 2, this is force 3, this is force 4, and this is force 5. Since the product of charges is not changing and distance between the charges is also not changing, all these forces are basically same with respect to each other. Go ahead or not. So this is one of the first property which you need to keep in your mind, that whether the charge become big or small, it does not matter. The matter is the product of the charges. If the product of charges is constant, then the forces applied between the charges will be also same. Whatever the force this 8 coulomb is applying on this 2 coulomb, the same force is applied by the 2 coulomb on the 8 coulomb charge. Are you able to get me or not? Because what is same? The product of charges is same and the distance between the charges is also same. Are you able to get me? Is this clear or not? So this is one of the biggest property which you need to understand, which you need to consider, which you need to always remember in your mind. Heard or not? Next thing, we got to know, we were talking about our electrostatic constant. So this is what I wanted to discuss much more in the greater sense about Coulomb's law. The point at which the force is zero changes based on the size. Never ever there is a force which is zero is going to be dependent on size, because this force is not even independent on the not even depends on the single charge. It is always dependent upon the product of the charges. So the point is very simple, that you should never ever consider the force to be present for the single charge. Okay, it's just like gravity. Whatever the force the moon is applying on earth, the same force is applied by earth on the moon. The force is zero somewhere, and we will get to know how to find it. We call it as equilibrium point, go ahead or not, but we'll come on that. That depends, that is found out using some different procedures. Okay, so remember that the forces are never ever dependent on size, except the force which we call it as F is equal to ma. So there are many forces. F is equal to ma, F is equal to g m1 m2 by r square. Now you got to know about the new force, which is k q1 q2 by r square. So these are the forces which are dependent upon the charges, dependent upon product of charges and product of masses. So that is why they are independent of shape and sizes. Go ahead or not. Okay. बट एफ इज इक्वल टू एम ए, दैट इज डिपेंडेंट अपॉन साइज. मतलब तुम जो सोच रहे हो ना, हाँ मतलब वो अलग चीज हो जाती है. इज दैट क्लियर और नॉट? Next thing, we were talking about the electrostatic constant. So this electrostatic constant ke is also denoted as k naught, which is means the electrostatic constant for air, which we call it as electrostatic constant for air. Got it or not? And for air, this k naught is given as 1 by 4 pi epsilon naught, और इस epsilon naught का नाम दिया गया permittivity of free space. In simple terms, कितना फ्री स्पेस में परमिशन है तुम्हारे पास एक दूसरे के ऊपर फोर्स लगाने के लिए, और दैट इज वाई कूलम फोर्स बिटवीन टू चार्जेस is given as 1 by 4 pi epsilon naught q1 q2 by r square, but this is only in the medium air. Yeah, e epsilon naught is defined only for air. Are you able to get me or not? Okay, and this is why k, if you just found out epsilon naught, I'll tell you the value tomorrow, but k cannot, value is given as 9 into 10 to the power of 9 Newton meter square per coulomb square, sorry, Newton meter square per coulomb square in SI systems for the air, right or not? But for different materials, different medium, I have a different value, which we will get to know about this in a much more greater detail tomorrow, right or not? So tomorrow we are going to discuss the permittivity, permeability, everything based upon the basis of medium distribution, and then we'll have some more too much problems of Coulomb's law, at least 15 problems. So be tuned tomorrow, and then we'll see that. तब तक के लिए टाटा बाय बाय एंड see you.